I've decided to make a last segment in section 5 of chapter 5 of some story problems. Probably not going to finish the solutions, but going to set these up. In class, we're going to do just a bunch of story problems together one day. So this is one of those kinds of problems where we have a total item and then actually, it's not a total and a cost. It looks like we buy 4 pine seedlings and 3 fir seedlings for a cost of $29. And then, I'm going to go ahead and change my color here. Then we go ahead and we buy 2 pine seedlings and 7 fir seedlings for a cost of $42. So actually both equations are going to have cost involved. And therefore, the question is to determine the cost of each type. That is the question. So what if we let X represent the cost of a pine, because that's what we want, is the cost of each type, and let's let Y represent the cost of a fir seedling. So if that's the cost per pine, X's, and there are 4 that we buy in the first bundle, how about if we take 4 times the cost plus 3 times the cost of the number of firs for a total cost of $29. In purple here, how about if we take the cost of 2 pines times the cost plus 7 firs times the cost for a total of $42. And now what I'm going to do is I'm going to set this up by determinants. So remember that using determinants, what we're going to do is we're going to put in the denominator the 4 and the 2 and the 3 and the 7. And then we're going to put in the numerator, see these C values? Those are going to go up here. The 29 and the 42 will go here. And then I'm going to bring up the 3 and the 7. And then let's go ahead and evaluate this. So 29 times 7 is 203. And then remember, you're going to subtract 42 times 3. 42 times 3 is 126. And that value is 77. Downstairs, 4 times 7 is 28. And then you're going to subtract 2 times 3, which is 6. So the denominator is 22. And we find out that the cost per pine seedling is $3.50. I'm going to put per pine. I could now take that solution and put it in for X in either of these equations. That's option number 1. Option number 2 is to go ahead and solve for Y. But remember, in the numerator, the C values, the 29 and the 42, will go over here. And then the 4 and the 2 from the denominator will go on the first column. Remember, the denominator stays 22. So now this 4 times 42 is 168, I believe. And then you subtract the 2 times 29, which is 58. And that total is 110. Divide by the 22. And that turns out to be $5 per fir. Don't forget, take your calculator, and I'm not going to do this, but take 4 times 350 plus 3 times 5 and see if that's 29. Take 2 times 350 plus 7 times 5 and see if that's 42 to check it. Okay, let's set up another story problem. An executive nearing retirement made 2 investments totaling $15,000. So maybe one was $5,000 and one was $10,000. We do want to find out how much was invested at each rate. So let's let X represent the dollar amount invested at 9%. And let's let Y represent the dollar amount invested at 10%. So we invest a total of $15,000. So my total equation might be X plus Y equals $15,000. But then we make interest, $1,432 worth of interest, by getting 9% on the X account and 10%, I'm going to put a decimal, real dark decimal there, on the Y account for a total of $1,432. Now please don't forget, you don't have to use determinants. So like for me, the top equation, Y would be 15,000 minus X. So if you'd like to substitute right there in for Y, 15,000 minus X, and clean up the second equation and solve it for X. That's, option number 1. Option number 2, heck, multiply this whole, here's your system. Multiply the top equation by 0.10 because it's easy to multiply by 0.10 versus 0.09. So that would allow you to do elimination. So say you multiplied this equation by a negative, actually 0.10. This x would become a negative 0.10x, a negative 0.10y, and 0.10 times this would be a negative 1500. So right here we'd have a negative 0.01x, and the negative 1500 and the 1432 would be a negative 68, I believe. And when you divide by a negative 0.01, so I'm just trying to show you and remind you of different ways to do this. X should be, I believe, $6,800 at the 9% account. Since there's a total of $15,000, Y would be $8,200 at the 10% account, and you could check these numbers in this equation. Let's see, I want to keep this kind of to a minimum. Let's skip number 1. Let's not actually skip number 1. Let's go ahead and let me tell you what the equations would be. The sum of two voltages is 100. If the higher voltage is doubled, let's say X is the higher voltage, and the other one is halved, the voltage becomes 155. That might be a nice one to solve by determinants. So in your denominator for X, you'd have this 1 and this 2, and then this 1 and 0.5. And in your numerator, you'd have the 100 and the 155, and then you'd have this 1 and the 0.5, and you could solve for X, for example. I'm going to skip this next one. We've done something like that real recently. This one's a little bit harder. It takes a machine 2 hours to process 6 items of one type and 2 items of the second type. I'm going to go down to the last sentence. Find the time required to process each of the 2 types. So let's let X represent the time for, I'm going to call it 1 type. And let's let Y represent the time for the second type. So it's the number of hours per item. It takes 2 hours to process 6 of this X and 2 of the Y. So 6 of the X and 2 of the Y takes 2 hours to process. It takes the same machine 4 hours, so over here 4 hours, to process 5 items of each type. So 5 of this one at so much time per item, and 5 of this one at so much time per item. And I'm just going to remind you of elimination. So say you wanted to make these both become 10s. You could multiply this top equation by 5 and the bottom equation by a negative 2 in order to make these become 10s. So this would become a 30x, and this would become a 10y, and then 2 times 5 would be 10. The second equation, you'd have a negative 10x. 5 times a negative 2 is a negative 10y, and 4 times a negative 2 is a negative 8. You add this right here, you get 20x equals 2, and you divide both sides by 20, and you get 2 over 20, which is 1 over 10, which is 0.1 hours, since all of this was in hours. And then you need to take that answer for X and put it in, probably here would be the easiest. So 6 times the 0.1 plus the 2y equals the 2 in order to solve for y, and we'll subtract 0.6 from both sides, and we'll have a 1.4 over here, and when you divide that by 2, it looks like y equals 0.7 hours for type Y to process. I think if anything, I'd set up one more question for you right now, and it would be this mixture problem that has to do with percent alcohol in a container. So it says how many liters of a mixture containing 70% alcohol. So I'm going to draw a container. And I want to know how many liters of this container that has 70% alcohol should be added to a mixture. So I want to know how many of that contains 20% alcohol to give me, in the end, I'm making this bucket look bigger. I want this to have 16 liters in it, and I want the final mixture to be a 50% combo, if you will, of this 70 and this 20. So it's not really a 50-50 split. For that to be the case, this would have to be a 30. This would have to be 20 under, and this is 20 over to get to this split. But what I'm going to do is I'm going to use this right here to give my total equation. I need to have 16 liters in the end. But then I'm going to pull the percent alcohol out of this one. So I'm going to pull the 70% alcohol out of the X container. X is the volume. You know, maybe this is 6 and this is 10 for a total of 16. I'm going to pull the 20% out of the Y container, and if I do that, I have to pull the 50% out of the 16-liter container. So this was the percentage times an amount. A percentage times an amount. So this right here, this equation would turn out 50% of 16 is 8. And my two equations I'm going to highlight in a minute here, and you can solve whatever method you'd like, would be the x plus y equals 16 and the 0.70x plus the 0.20y equals 8. And I'm just going to tell you that I found that x equals 9.6 liters, and therefore those to total to be 16, this has to be 6.4 liters. I'm going to finish this off by saying it's the 70% solution, and this is the 20% solution, and I should take these answers and check them in both of my equations. We'll do more story problems together when we get together. I'll leave the rest of these go for now, and then we'll move on to a system of equations in 3 variables.